Hey, welcome back to Mr. PL's with Algebra. This is Unit 2, Topic 2, Lesson 15. This is a lesson which explores the relationship between x and y and find how they're related to each other in both linear and exponential equations. Question number 1 on the warm-up says, give an example of a discrete function. So I would say the total cost of going to a football game is a function of how many tickets you buy. And the reason why that would be discrete is because you can't buy half a ticket. An example of a continuous function would be kind of like that buying candy. So the total cost of buying candy is a function of how many pounds you buy. So you can buy 2.5 pounds of candy and then pay per pound, and therefore that's continuous because you can buy any amount of candy. As long as the independent variable can be anything, it's continuous. If the independent variable can't be anything, and if it can only be like certain things, usually like whole numbers or maybe even integers, then it would be discrete if it can only be those things. All right, question number 3 looks very similar to the question we've done in the past because we've actually done this question before. Negative 6250 was the starting point, negative 10 was the ending point. So if we're trying to find what's in between, we could find our geometric and arithmetic means, or we can say to ourselves that these two numbers are 6,240 apart. Now, if you divide that by 1, 2, 3, 4 common differences, then that's going to be 1,560 each. So you would just simply add 1,560 to the previous term. So you got negative 6250. Oh, that didn't work. Negative 6250 plus 1,560. Didn't work again. 6250 plus 1,560 makes negative 4,690. Add another 1,560 and you get negative 3,130. Plus another 1,560, it would be negative 1,570. And you can see if I add another 1,560 to that, it's going to be equal right there. Now, the next question, I'm just going to save a little bit of time here. It happens to be times 1/5 is the equation. So you can just do this times what to the 4th power equals negative 10 and solve for the ratio. And it happens to be 1/5. So all you got to do is divide the number by 5 each time. So we've got 6250 negative divided by 5 is negative 1250. Divide that by 5 again. Clear that out. So divide by 5, because that's times 1/5, or times 0.2. That's going to give you negative 250. Divide by 5 again is going to give you negative 50. Divide by 5 again gives you negative 10. Now, the other thing I might want to think of is, would multiplying by negative 0.2 also work? Negative, positive, negative, positive, negative. Yes, it would. So technically there are two answers to the geometric sequence, and both a positive and a negative ratio would both work. All right, so getting to this lesson, which I'm going to be doing a lot of skipping of most of the stuff. And first of all, the paper was wrong, so you got some changes here. If you put these numbers into this equation, you don't get the number that was written on the paper. So it says, can you change the equation to make it x equals? So I will take a little bit of time doing that. So we've got this equation, which is y equals 0.7x minus 3. If I want to solve this for x, I would just do what I did before earlier in the year, which is called literal equations. So we've got y plus 3 equals 0.7x. And then I divide both sides by 0.7, and there's my answer. So x equals 0.7y plus, well, what is 3 divided by 0.7? 3 divided by 0.7 gives me, ooh, that's a long decimal. So I'm just going to leave it as negative 3 divided by 0.7. Okay, so that would be taking a y equals and turning it into x equals. So that's one of the things that we'll be talking about today. So what if you have an exponential function? How do I make this x equals? Problem with that is exponential functions don't have an x-intercept. Well, not all of them. Some of them don't. Because the nature of a hyperbola doesn't always have to cross the x-axis, because it has what we call an asymptote, meaning this line is going to go infinitely down to the left if you're looking at it backwards, but it'll never cross the x-axis. So in this case, not all exponential functions will have an x-intercept, meaning if you write it if I change this equation to make it x equals, I'm going to have an x on both sides. It's going to be like the third root of y, I'm sorry, the x root of y equals 3 or something like that. So it's not really going to work out. So the graph of negative 1/2 x plus 3, so that's what we got right here. So it starts at 3 and it goes down 1 for every right 2. So the x-intercept happens to be right here at 6. And I could solve for that if I put 0 in for y and solve. Because anytime it's an x-intercept, y must be 0. It has a height of 0. So if I put 0 in here, I'm going to end up getting 6 if I solve it. Same thing goes for these questions. These questions, A, B, C, I really can't do them on the flip chart because you're given answers. You're being told that the answer was 5 and you're trying to solve for x. I'm not really going to save much time on doing this, so if I just tell you what I would do, I would subtract 3 from both sides. That would make this 2, and then multiply both sides by negative 2. That's the opposite of this. So 2 times negative 2 would be negative 4. So that means x would be negative 4 for A. So A would be when a height of 5, it should be right 4. And just to prove that, let me see. So what do we have here? If y is 5, when does it have, oh, it's negative 4. Sorry. That's what I get for doing it in my head. When does it have a height of 5? At negative 4. So the answer was negative 4. So as I mistakenly said, so I subtracted 3 from both sides. That makes 2, and then multiply both sides by negative 2. That's what I forgot. 2 times negative 2 is negative 4. So basically all you're doing is, if that's the answer, if that's the y, what x would that be? Alright, so same thing can be done for exponential functions. If you put the answer in for y, you can solve for x and figure out where that point would land on that function. That would work. Even though it doesn't have an x-intercept, does not matter. So all these questions can be solved. We've actually done most of these questions in the past, and just to remind you, we just have to set them to the same base. 1/9 is the same as 3 to the negative second, and once the bases are the same, then the exponents must also be the same. So just a reminder of what we've done in the past. 9 is the same as 3 squared equals 3 to the x. Bases are the same. Exponents must also be the same. Very easy. But when you get to questions, yeah, I'm skipping that square root one because we didn't do that yet. Same with these. I'm not going to do these as well because there's no way to make the bases the same. So you would have to do something which is called algorithm. I'm sorry, something we have to do called logarithms. Logarithms. These are logarithmic functions. You would have to take the log of both sides. I don't have time to get into all that right now, though. Just search for logarithmic functions if you want to figure out how to do that. Change the base. Same with all these questions. Very similar to what we've done in the past. This is the same thing as 5 to the third power. X must be 3. Okay, I'm not going to go through those as well. So let's get into the homework. If the pattern, here we go. There are 2 girls in my grandmother's family, and my mother and my aunt. They each had 3 daughters. My 2 sisters, 3 cousins, and 1 each had 3 daughters. So this is very confusing, but basically what they're telling you is happening is that each mother is having 3 more daughters. Each one of the daughters is having 3 daughters. Oh, well, I just said that. So there was a mother here, and then she had 3 daughters, and then all of those kids had 3 daughters. I'm making sort of a bad family tree here. So it's going to grow exponentially. So we had 1 person to begin with. So there are 2 girls in my grandmother's family. Okay, so there's 2 people to begin with. And each person is having a rate of 3 more people to the x power. Okay, so I believe I just wrote this out. Started with 2 people, and then it triples x amount of times. All right, so that means started with 2 people, and then triples. Times 3 would be 6, times 3 would be 18, times 3 would be 54. I'm probably going to need that calculator. See, times 3 again would be 162, is that right? So 3 times 4 is 12, carry the 1, 15, 16, 162. I hope I did this right. Let me see, 3 times, oh, yep, I knew there was a mistake. Let's go back a second. 3 times 6 is 18. 3 times that is 3 times 8, 24. 3, 4, 54. Times 3 again. There's no mistake. Can't remember what I wrote. 3 times 4 is 12. Carry the 1. 15, 60. 162. Times 3 again. 6, 18. Carry the 1. 486. Didn't check with the calculator, so you might want to do that. Graph the pattern. If this continuous or discrete, well, it's dealing with people, so it's going to be discrete. Can't have half a person. Graphing that pattern, going to have to be a little bit strategic about this. So if this is 0, I'm going to space it out so it's every 2. That's 1, that's 2, that's 3, that's 4, that's 5. Sorry for my messiness. And then going up, I need to get the numbers all the way up to 486. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 blocks going up. If I make each one 50, it looks like it should fit. So that's going to be 100, 200, 300, pen, come on, here we go, 500, perfect. So 0 was 2, so that's so low you can't even tell. 1 was 6, still so low you can't even tell. 2 was 18, still very low. 3 was 54, slightly above right there. 4 was 162, about right there. 5 was 486, is about right there. So it is a hyperbola because it's an exponential equation. And it does not have an x-intercept, even though it does look like it would. It's going to go down here to the left infinitely and never hit. All right, that's it. Please give it a like if I helped you learn something, and follow if you haven't done so already. Have a great day.